I might as well get started. So this is a workshop on creating subgraphs, indexing blockchain data, and querying that data from Unity game engine. My name is Christian Sumito. I'm the founder of Rorschach. I'm a former Microsoft engineer. I worked on Windows 10, Xbox, and xCloud. xCloud in the last 2 years was essentially my baby.
Amazing.
Thank you. It was really fun. It's just I wanted to do something else more interesting.
Sorry, but why no Android TV official support so I can run it on my Shield? I kept asking Microsoft because I'm side loading it to my Shield and stuff. And I'm like, come on, Apple TV.
It works.
Yep.
So technically it works. It's just that Google doesn't really want our stuff on their on like their more specialized hardware because they have their own Stadia, and so they want like, yeah. Anyways, Google and Apple really don't like to play well with Microsoft, and they keep blocking our apps from deploying easily to their platform. So it's kind of annoying, but it is what it is.
That's a good point.
But yeah, and I'm a former engineer at EA and Autodesk. I worked on NCAA Football 14, which got canned because of the whole NCAA controversy. But oh shit. But anyways, so that's a little bit about me. So let's get started on today's content. So today's content is about subgraphs and indexing blockchain data. We are going to create and deploy a custom subgraph on the graph, and then we're going to query that subgraph data from Unity, and then we're going to verify that data and query the blockchain from Unity using the ChainSafe's gaming SDK. So why exactly are we doing this? Why exactly am I doing this workshop? Blockchain data querying is currently very basic. You can only really query whatever data is available from the contract API. So whatever smart contract you write, you have to expose information from there, and then that's the only information you can essentially query. With ChainSafe's gaming SDK, there's a few more additional queries that you can do. There's a get all ERC21 and a get all ERC1155, which allows you to query for a wallet, all the assets in a wallet. But with that, it's still a little bit limited because once you have all the information, let's say a wallet has, let's say, 1,000 NFTs on it, then you'd have to go and parse that manually for the specific asset that you're looking for. In addition to being able to query whatever information is already available, or whatever data is already queryable from the contract API. These are great, but you can't really make complex queries. You can't make queries like querying all the assets, querying all the users that own a specific asset, or you can't query all the assets that a user owns, but the quantity is greater than 5, or you can't make queries. You can't make a query that gets all the assets that a user acquired before a specific timestamp, or you can't even use the metadata. You can't make queries based off of metadata. Like you can't query an asset whose all the assets in a contract that, let's say, starts with the letter A, for example. So currently there's no easy way to go do that. But with subgraphs and blockchain indexing, that's essentially a solution. The Graph developed a decentralized protocol for indexing and querying blockchains, which makes it possible to query data from the blockchain that's normally difficult to query directly. Subgraphs define which data the graph will index from your content contract and from the blockchain, and it defines how it will be stored. Once it's deployed, it's actually going to be part of like a global set of a global graph of data that the graph has set up. In a subgraph, you will essentially define the types of entities that your data is indexed, as well as relationships between those entities. These relationships will define how you will query the information and how you want to make that available. So essentially, you will define how the information is indexed and how it's created, and then you will define how you will query that information, what types of queries are available based off of the information, based off of the essentially the schema that you created. For this workshop, is pretty basic. All you'll essentially need are a text editor, a terminal, a GitHub account in order for you to create a subgraph, Node.js in order for you to get the necessary library, tools, Unity game engine, and currently I'm using the Optimism Coven testnet. The subgraph repo is linked below for the complete subgraph demo. With that, let's get started on the workshop. Okay. So to start off, I wanted to show a smart contract that was developed. So this is Rorschach's alpha testnet. Here we can deploy smart contracts. So just fill in the information, and then it would deploy a smart contract. And then once that smart contract is deployed, you can create assets, and there are different type of assets on there. So the smart contract that we're going to use is currently this one. I pre-deployed it mainly because it's already up there and already has some assets in it. So this is the smart contract that we're going to use. So first we're going to install the CLI for the graph in order for us to create a smart contract. So in order for us to create a subgraph. But of course that's already installed. I think it's just going to update if there's anything to update. It's just npm installed sg at graph protocol /graph CLI. Oh, there's someone in the chat. Oh, no, it's fine. Oh man, I should have did this beforehand. Anyways, while that's working, I'll move, okay, in the subgraph. Okay, so I'm going to make a new directory for the new subgraph that we're going to create. Demo subgraph. And then is it done? Okay, it's not yet done. So here we're going to initialize the graph. So this is graph init product -- product hosted service. The graph has several types of services. The graph.com. They have a subgraph studio, which is a place you can just create your subgraph manually, but this is only supported for Ethereum mainnet. So this is why we're using the hosted service. The hosted service can support many different types of I can't link it. But let me rephrase that. The hosted service supports many different EVM blockchains. So in this case, we're using Optimistic Coven testnet. Oh, it's not done yet. Oh, that's done. Okay, so let's run that. Protocol Ethereum. Let's call a subgraph demo subgraph. Oh, sorry. Check. Sorry, what was the Rorschach -dev / and then this subgraph name, demo subgraph. So what this is this is your GitHub account / demo subgraph. So in here, you want to in the graph, you want to sign in using your GitHub account, and then when you open up dashboard, it'll give you an access token. So, but first, let's continue with this demo subgraph. Oops. And we're going to choose Optimism Coven. Contract address is this one, assuming you've already deployed. And then because the smart contract that I have is specific to the Rorschach protocol, I need to use the ABI for that contract. Content.json. Content. So now it's generating all this, generating the scaffolding. This will just take a couple minutes, but this will generate all the necessary code for creating a subgraph, or most of it anyway. Excuse me. Yeah, sorry, this will only take a couple minutes. Does anyone have any other questions so far? Feel free to just put it in the chat. Hello, Nielsen. Do you have a question, Nielsen? Okay, I guess not. Oh, typing it out. Okay. Oh, in the meantime, I'm gonna once it's done, we're going to run graph auth, and with the access token here, what that sets is when we deploy the subgraph, it automatically sends it to here. Deployment key. Oh, oops. Deployment key is that. Let me create a subgraph. Demo subgraph 2. Oh, demo subgraph 2. Workshop. Hosted service, and then deployment key. Okay, that's it. Nielsen had a question, was wondering who you will be approaching and what games you're trying to bring this first. For Rorschach or for, oh, okay, I'll answer at the end then. I'll just finish the demo first, or the workshop first. Okay, so once that's set up, we can start with the code. Oops. On this side. Oops. CD demo. Okay. Oh, is it the wrong one? Oh, demo subgraph 2. Oops, that's the one. Apologies. So this is what the subgraph packages look like. This will contain several important files, including the YAML file, the schema, and the mapping. The subgraph YAML, in here you will define what the specific contracts that the subgraph is listening for, ones you want to keep track of. It'll contain the ABI information. So where is it? The link to the ABI in here. This is the one I linked earlier. And it will contain the event handler. So the way that the subgraph works is that for every event that your smart contract triggers, it will listen for those events, and then it will handle and parse that information in order for it to build whatever schema you create in here. And that's how it builds the information, the relationships and the entities that you'll be able to query down the line. And then you can also set the specific network, that you're on. So in this case, we're on Optimism Coven. The schema is the GraphQL schema is what you define in order for. The GraphQL schema is what data is stored in your subgraph, and it also defines how you can query these information. So in here, we will define different types of entities and different types of relationships. We'll go do that in a little bit. And the mapping assembly script is the assembly code the assembly script code that translates the events into entities defined in your schema. So here, for every event that the smart contract has, you'd want to have a handler here, and depending on what is how you want the data to be processed, you would define that here. Okay, so let's start off with defining the schema. So in our schema here, first we're going to kill all that, and then we're going to define the content, our first entity as the content. This is the overall entity that will hold the location for, or that will hold the contract. There are several important things to keep in mind, because the first is that there are such things as optional versus required fields. So the main required field that you need to keep track of, that they keep notice of, is the ID. And the ID is what identifies every single entity in that set. So each entity that we create, so several other entities, so users, entity, every single one of them needs an ID. This is a special type. This realistically is just a string, but it is special to the schema. Type asset entity ID. Okay, these are the three entities that we're going to define for now. There are many different built-in scalar types. There's let's add that here. There are bytes, ID, which is what I mentioned earlier, string, boolean, int, big int, and big decimal. Bytes essentially function as what you would be using if you wanted to store an address in here. String is fairly straightforward. Boolean is very straightforward. Ints, big ints, are used for Ethereum UN32 and above, essentially all the way to UN256. Anything smaller than UN32, you would essentially be using int. Decimal is high precision decimals. I think it rounds to the nearest 34 significant, big decimal, rounds to significant digits. Okay. There are also enums. You can define enums in here. Enums are a little bit special in that it's as simple as enum and then the name of the enum. So let's say type, enum type, and then type A, type B, for example. And the way you would be using an enum inside here is actually as a string. So in the code, you would equate that to type B. But anyways, so these are your entities. Now we want to define the relationships between these entities. There are many types of entities, relationships. There's one-to-one, one-to-many, and many-to-many. First, let's define one-to-one relationships. So let's say each user, so each asset, each user can have, let's say, assets that they owned asset. If each user could only have its own asset, we would define it as like this, and asset owner user, like that. So what this essentially means is that for this relationship, this owned asset can be owned, this user can own one asset, and this asset can be owned by one user. That's how you would define a one-to-one relationship. For a one-to-many, it's a bit more interesting. So let's define a assets set to parent. So in this case, what this essentially means is that for many assets, a content can have many assets, but an asset can only have one parent. It can only belong to one to one parent. Now, in the mappings, when you start defining the relationship and how they're created, the easiest way for us to be able to do that is to have the graph derive those relationships. So in this case, you can do derived from, and then the field of where that's derived. So in this case, parent. So what this does essentially is whenever you create an asset and you define the parent as a specific content entity, the content will automatically add that asset into this array. And there are other information that you can add, like token ID. Sorry. Here, token ID for that asset, current supply, max supply, and then And so the most interesting relationship that can come out are many to many. So in this case, for example, as I mentioned earlier, you can have a user, you can have owned assets here and owners here. User asset. But of course, a user can have many assets, and an asset can be owned by many users. So the best way to actually go do that is to create an entity relationship. So let's say our fourth entity, which can be asset balance. And in here, we have, of course, we define the ID and we define the owner. And we define the asset. And of course, let's say define the amount. Right? And the easiest way for us to define this relationship is to just have it derived. Derived from owners, because it's a many to many. Instead of user, this is now asset balance. And it's defined from owner, because that's, defined from asset. And here is the same thing, because that's the relationship, that's these two's relationship. And this is defined from owner. So with that, we have essentially built our small small schema. With this, you can essentially start querying. With this schema, you can essentially query, let's say, the user and all of its assets, and then based off of the assets that it owns, you can then query the assets information, such as current supply, max supplies, all that stuff. Okay. Next, we'll define the different mappings from the different mappings that will actually let us create those entities. So let's just delete all this, because that's not that interesting. The one that we really care about is the one that we really care about is mint and single transfer right now. So in mint, this is the first thing that will get called whenever an asset is created. Burn is the opposite, whenever we call whenever asset is burned. And then transfer single is going to get called whenever an asset is transferred between users. So in mint, first thing we want to do is define the content. So this is the content entity. So let content equal content.load event dot. So in this case, we want to try to get the initialized content. And the way we would do that is we would use the event address as the ID to figure out if that content entity has already existed. So we can't directly use these addresses. We need to convert them to hex string, because that's what the ID. Before all that, apologies. Before all that, we need to run yarn cogen. This refreshes the generated content, which gets picked up by mapping. And here we have to define the different entities that we created earlier in the schema. So here we want to define content, user, asset, and asset balance. As content contract because they clash. Okay. So first we want to define the content once it's created, right? However, we don't know, we need to check whether or not that content exists first. If content is null, then we actually go and create it. Content equals new content event.address to hex string. And then for every single time we change anything within an entity, we have to save it. Okay. So with that created, now we have a content contract. And then first we have to, next we define all the parameters to our events. So let's get the asset IDs, event dot params dot data dot token IDs. Let's get the amounts. And dot params dot data dot amounts, and let's get the receiver address of the mint, whoever's minting it. Let receiver address equal to event dot params dot data dot to. Okay. Let's create the receiver, the person who's going to receive all this information, all the assets that was minted. Let receiver is equal to user.load receiver dot to hex string. Because we don't know if that receiver already exists or not, we have to create that if it doesn't already exist. Receiver user receiver address to hex string receiver save. The nice thing about these type scripts is that we can actually access the information from the smart contract itself. So if the event doesn't provide the necessary information that we need, we can go and query that information. We can manually go and query that information. So what we want to do here is for each create all the assets that are being minted. So we do first, let's create do a for loop for let I equal 0, I is less than assets IDs dot length, oops, plus I. This is just similar to C++ or C++, Java, whatever syntax you're mostly used to. Here we want to define the ID of the newly created asset. Let asset ID equal to the thing to note here is that we can use just the token ID here, but since the contract is a little bit, since you can eventually use more than one contract, we want to add the contract address as part of the ID. So in this case, we're just going to do content.id plus and then a dash, oops, and then the asset IDs index, the token ID to hex string, and then we'll create the asset. Let asset equal asset.load to check if it already exists. If it doesn't, we'll go ahead and create that asset. Asset ID. Okay. Here we'll define the necessary information from the asset. So as we created earlier, it has ID, parent token ID, current, and max supply. Anything that's derived, you don't actually have to fill in. So in this case, asset dot token ID is equal to just this one. Asset dot parent, as defined earlier, we can just easily say, we can easily use the content ID and that content dot ID, and that will automatically be derived on the other end. Asset dot current supply big int from I32. So what this does is, since current supply is actually a big int, we need to set that to 0 via this this method. Asset max supply. Now, we don't know what the max supply is because it's not included in the mint event. So what we actually want to go do is we want to go and query the smart contract for that. Now, the graph allows you to query these smart contracts easily. So let's define that that contract, and that's why we have this content contract up here that was from the generated folder when we called CodeGen. So let's content contract, and we use this bind function in order for it to bind the specific address that we want. So in this case, we're using event.address, which is the address of the event, the address of the smart contract that generated this event, and that's where we get this an instance of that smart contract. So in this case, what we can, and then we can just call whatever functions are available on that smart contract. So in this case, we'll just do max supply. We'll call them max supply, and then pass the ID of that asset. Now, normally we would add say asset.save here, but since we need to go and add the current supply that's being minted here, asset.current supply dot equals, we'll do it on the outside, asset.current supply. One thing to note is that because current supply is a big int, we can't just use plus the plus signs. What we will do is use the plus function amounts I, and then we'll save it. Okay, and with that, every single time an asset is minted, we can create assets, an asset entity if the asset entity doesn't already exist, and then update the necessary current supply. How much time do I have left? Okay, let's. Oh, sorry. Jeremy asked, thought token ID is unique, so there can only be one owner in this case. Since everything is minted by you, increase the token ID. So you could actually just go ahead and instead of using asset ID as whatever as content minus and then the name of and then asset token ID. In this case, we're using So in this case, the contents contract is actually an ERC 1155. Based off of ERC 1155. So each token ID is unique, but the instances can vary. If that helps. So the token ID does get incremented over time, but since over time you don't really know how many content contracts there are, yeah, since you don't really know how many content contracts there are going to be, in this case, there's only going to be one. But in the future, you could have two different content contracts that can call, that can listen, that can call them in function that you're listening to. And that's why we use the, okay. Yeah, it's a bit different because, yeah, that makes sense. Okay. Yeah, so if it was at 721, then yeah, feel free to define the asset ID here, however you see fit. This is just an example. So yeah, the rest of them are going to be pretty much the same. The way you handle each of these, the rest of the functions is up to you. But in this case, I'm just going to copy paste some existing functions that I already prepared. So single transfer. So in this case, we also check whether so for single transfer, we also check for whether or not the content contract is already created. And if so, here we actually go ahead and create an asset balance for every relationship, for every asset that's being created. And then, so we add that to the receiver, create a receiver if necessary, and then create an asset balance for that assets relationship with that receiver. And if the sender already exists, or if it's not the zero address, then we deduct a balance from that sender ID. So this is pretty straightforward. This just makes sure that the data on the subgraph corresponds correctly with the assets that are being sent and received. And it's the same for, it should be roughly the same for the transfer batch, except for the fact that this one has, this one can send multiple assets a single time. Again, these are ERC 1155, so they can easily transfer more than one asset at a time. Let's see, is there anything else? Oh, let me copy the burn function, the handle burn. So everything else is relatively straightforward. Handle transfer manages the relationships that are created when an asset is transferred between users. Handle batch is just the same as single transfer, except for more than one asset. And handle burn will delete or subtract asset balances from a user, sorry, as well as from the asset. So with that, let's say we finished managing the, let's say we finished creating the relationships or the mapping. So what we want to do now is make sure that it builds, which just runs yarn build. Hopefully that builds. Okay, now that it's built, what we want to do is make sure that it can actually deploy. And that's as simple as yarn deploy. So what this does is it builds the subgraph that we created locally and then deploys it to the hosted service. Hopefully that's correct. Hopefully that does that. Okay. Fails to deploy graph. Oh, right. Oops. Subgraph. Demo subgraph. Yeah, sorry. I forgot to change that to 2. From earlier. Let's build that again. And then deploy. Okay. So now in here, if you refresh that, this subgraph is now syncing with the blockchain. Now what it's doing is it's reading all the blocks and then processing all the blocks to build the relationships that exist here. The relationship that we literally just wrote. So this will take a little bit, maybe like a couple minutes. In the meantime, what I want to do is I want to create a Unity project to while this is loading, all this is syncing. Okay, so in here, so I've currently installed the latest Unity. Actually, we're just going to use 2020.3 Unity Workshop. Let's just do demo workshop, and okay. Yeah, so while the subgraph is loading, we are creating we're creating a demo project that we'll be using to query these blockchain data. Sorry, the Unity is opening on a different screen. I can't move it. So as you can see, everything's being processed. Actually, the smart contract that I had used, this one, is being used, is currently live, and so it has a lot of entities inside it. So it's taking a little bit to load because it needs to process that. So currently there are about 3,000 entities that has been created, but it still needs to process every single block to create those relationships, those entities. Yeah. So here's that game. Okay, while that's loading, here I will load, first I will load the Rorschach SDK. And I'm doing that because it just makes this workshop much easier. Where'd it go? So I'm going to load the Rorschach SDK. And you can get that from oops, what's going on? You can get that from here, which is github.com/Rorschach Unity SDK releases. Just pick that first one. So, oops, where'd it go? Oh, yeah. And the reason I'm just pulling this in because it has all the necessary packages for querying that data. Inside here, inside the Rorschach SDK, it contains a GraphQL library that will make querying the subgraph easier in the packages. It also contains ChainSafe's gaming SDK, which is this one, the Web3 Unity. That's up to date with ChainSafe's, all of ChainSafe's SDK. It also has a Wallet Connect Unity extension package that allows us to connect. That allows us to connect a mobile wallet to any Unity game. So let's see, is this done? Okay, so now that it's finished, oops, what we can do is we can query all the information all the entities that we just created. So in here, so let's say we wanted to query all the users. Oops, let's say first 10 users that show up, ID asset owner. Oh, I misspelled it. So now it has it now you can you can make different types of more interesting queries. So let's say asset balance. Let's say you only wanted to show the first 5 assets that a user owns. You can make those queries like that, or you can let's do max supply, or sorry, max asset. Oh, sorry, these are relationship asset max supply. So now you can create more interesting queries like that, where you're trying to get the user and the assets that the user have, and these are the asset balances. For each asset balance, you want to get the asset and check out the max supply for each asset. So here's your first user. Here's your user. Here's the asset that user owns, and here's the ID for that asset. Oh, let's do token ID. Token ID 0, and it has a max supply of whatever UN max 32, UN 256 max. So you can make more interesting queries like that. So in the once we've created all of the necessary, so once we've dropped the Rorschach SDK in there, which contains all the necessary packages, let's go ahead and let me just drop in a wallet. Let's make that bigger. Prefab. Let's make that bigger. Oops. So what this does, all this does is creates a wallet prefab such that when you log in, it generates a QR code which you can use your mobile wallet in order for you to log in with your mobile wallet. Next, what we want to do is let's see, what was it? Okay, so now what we want to do is actually create the custom queries that we want to use in order for us to query our subgraph like this. So first things first, we want to create a folder in here. Oops. Let's call it source. Okay, and here we want to create a resources folder, as well as a scripts folder. In the resources folder, we want to create a let me just open that folder where yeah. Okay. Okay. So in this resources folder, first things first, we want to create a text file that contains the query that we're going to use in order for us to query the subgraph. Let's call this get wallet assets text. So similar to this, where we want to query all the user's assets. Let's copy that. Oh, current supply. Let's kill that. Let's do that amount. So we want to copy that and essentially paste that in here. Here, query get wallet assets. The only difference between this query and the wallet connect, the Unity query is that you need to have since these are strictly strings, you need to double up these queries. Oops. Or these brackets, I mean. So what we want to do is for the user that we want to create, we want to do ID, user ID 0. Now what this does is it allows us to replace this 0, this specific one, with the first entry in our query layer. So as we're going to keep track of this. Assets, we want to do here, make it more interesting. Amount greater than 0. So what we want to do here is we want to make a query where the query returns the user that we're looking for, get that user's ID, get the assets that have the assets in that wallet whose amount is greater than 0, return the amount and return the asset and its token ID. So that's the resource query that we want to do. And in order for us to query that from Unity, we'll firstly create a script. Let's see, it's called as get wallet assets.cs. And then open that here. Firstly, we want to make sure that it's using the Rorschach Sdk because we want this to inherit from a query base, which is found in the Rorschach repo, Rorschach library. So query base. This is just basic. Gives you the ability to load a query as well as get the make that query to the blockchain, or sorry, to the subgraph. First things first, we want to kill all of that. Don't need this, and all we want to do is expose a fetch function. So what we want to do is public static async task return data object, which we'll define later. Fetch and the string of and then the parameter of the wallet address that we want to pass in. Oops. Okay. First, we need to load the query. So first things first, we want to load that query using the query base load query function. So, and then pass in query, and then pass in the text address in the resource. So in this case, all we need to do is get wallet assets. And that should, and what this actually loads is this string. Okay. Next, we want to do is pass in where function parameters. So in this case, string query with params is equal to string dot format query, which we just got earlier, and the wallet address. The only caveat is that subgraphs only work with lowercase, so we have to send everything to lower. We forgot to have a few of the include a few necessary libraries. This is for the string. This is for the big ints. This is for making sure that since these are tasks, we have to make sure that that's there. And networking, because for the get queries, for the specific queries. Now we want to post that query. This one's fairly straightforward. This one gets a return data string, await post async, which is this function. It does the necessary query for us. All we need to pass in is the query API here. And the query, the actual query. And that's it. And then we want to return a parsed version of JSON utility from JSON return data. We want to parse that return data, right? And so the way that we parse this actually is, first of all, the return looks something like this, where the first thing is the data, and then the users, because it's based off of this. So user IDs, owner assets, amount, asset, token ID. So in this case, user ID, your owner assets, amount, asset, token ID, like so. So the way that it serializes that into an object is we have to define these relationships like so. So the return data, which is this one, the first parameter in there is data. The first object in there is data, and then inside that you have user, and inside user you have the ID as well as these ID as well as the owner assets. And then in the asset balance you have the amount and the actual asset. And in the asset, you have your token ID. Oops. Token ID. And so once this query is made, it'll automatically parse that string into this JSON return data. And so that's how we make that query. Now, in order for us, let's make an example out of, let's make that a better example, let's show a better example. Let's see, let's create an empty object. Let's call it manager. In here, let's create a sources, let's create a script that does wallet manager. Since I'm lacking a bit of time, I'm just going to, since I kind of rambled on, I'm just going to copy and paste some boilerplate code that I already had. So in here, all we define is the game object, which is the game object for the load UI. Oops. name object for the load UI. Define the chain Ethereum. Networking is the Coven optimistic Coven. The contract that we defined earlier, and then the RPC for the network. Here, all this is doing is loading the wallet once it exists, and then once it's found a connection, it will send it to here, which prints the active session. So what we want to do is add the wallet manager, pass the that should be fine for now. Pass that wallet manager, pass that wallet UI. Okay. Okay, so that should work. That should work to get, oops. Sorry, just a second. Just a second. Sorry, MetaMask. Huh. Apologies. MetaMask wallet is being. It's never working. It never works well during a demo. Okay, let me close that and try it again. Okay, there we go. So MetaMask wallet works. We confirm that it's loading the wallet. Okay, so now what we want to do is in the wallet, we want to make that query. I'm going to do public get wallet assets dot return data is equal to return data. Here, I want to do return data is equal to await get wallets dot fetch, and then pass the load wallet. Okay. From there, it's able to query all data in this wallet that whose assets are greater than 0. And so now that we're able to query data from the subgraph, what we want to do next is use so the subgraph is actually non-deterministic. So some queries get called before others. So as well as some events on the blockchain happen immediately before your query can actually get called. So in order for you to confirm that those assets, that information that you get from the subgraph is actually correct, what you want to do is to verify that the more important information by checking the blockchain directly. So in this case, what we want to do is we want to check await. We want to verify using ChainSafe's SDK, verify assets And then I'll just copy this in here. Oops. So in this case, all the verify assets does is for each of the asset balance that actually gets pulled in. Oops. Turn data. What we want to do is we want to use the ERC1155 function call, balance of function call from the ChainSafe SDK, and then make sure that that asset is actually correct. And once it is correct, what we want to do, as an example, is to get the public URI for that information, or for those assets. So in this case, we could, and when we get the public URI, in this case, we're using the ERC1155 URI call from ChainSafe's SDK. We can also use content manager from Rorschach's gaming SDK, token URI or token URI with version. But these are specific to these are specific to Rorschach smart contracts, and underneath it just uses the ChainSafe EVM function call, which is what this uses underneath. So as a quick reminder, Rorschach's SDK essentially use ChainSafe's SDK. So you can use any of these to get the correct URI from the smart contracts. So if we run that again one last time, oops, what? Turn data. User. What did I do? 7 user. Oh. Sorry about that. Minor fixes. So if you run that again, it's able to get all the balance and then query all the URI from the smart contract from the smart contract. With that, sorry, it took way too long. I'm glad we pushed this to about 1.5 hours. Yeah, with that, that's the demo for the project, for the creating a subgraph, indexing blockchain information, and making those queries from Unity Game Engine. I will be posting the demo or the workshop up on YouTube for later, as well as posting all the code in this workshop on our GitHub. Does anyone have any specific questions? Was that relatively clear? Sorry, I kind of ended up rambling, so I hope you guys probably have a lot of questions.
Yeah, first I'll just like to say on behalf of ChainSafe, thank you for that awesome presentation. And I'll just unmute, let everybody have the ability to unmute themselves and ask any questions.
Yeah, I'll drop a YouTube link once I've cleaned it up a little bit. Yeah, I'll drop it on the ChainSafe and the Rorschach Discords, as well as tweet it out.
Thank you.
Cool. Was the presentation relatively straightforward? Does anyone have any specific questions with regards to creating subgraphs, how to access it from the Unity Game Engine, why we're using subgraphs in this case? that's pretty good. I'm glad you guys liked it. But yeah, sorry, Alex, do you have any questions? You're muted.
Oh, I was just gonna say, like, we've been exploring the graph as well, so I'm stoked that, you know, Leon and folks can check this out, and that it'll just serve as like a good reference for how stuff can be done, and also just like getting familiar with how Rorschach does things and stuff like that. It's awesome that you were able to share.
Cool. Yeah. The GraphQL library that we're using is really old. So if ChainSafe ends up creating their own like GraphQL libraries themselves, then that would be great, because the ones we're using is, I think, 4, 5, 6 years old now, and
It brutal.
Yeah, it hasn't been updated at all in like at least a couple of years. So, but it was the only available one. It was the only decent GraphQL library on Unity. So,
Gotta use what you got.
Yeah, exactly.
Can be lonely on the bleeding edge.
Yeah, pretty much.
For real.
Cool. Well, super appreciate it.
Yeah, definitely. Thanks for coming, you guys. I really appreciate it. If you guys have any further questions, I'm always available on the ChainSafe Discord. If you guys have any questions, I'm also available on the Rorschach Discord. Yeah, or you can just add me on Discord and then just send me a PM. I can definitely give you guys answers as much as I can.
Awesome. Thank you so much.
Perfect.
Awesome. Gents.
Take it easy, y'all. Happy weekend.
Have a good
Thanks,
weekend.
okay.
Thanks a lot for
Peace.
coming. Peace.